There was this asteroid that collided with Earth over Chelyabinsk in the Soviet Union and Russia, that was visible to everybody in broad daylight and you had to avert your eyes when it happened. They felt a shock wave and the shock wave broke windows and sent nearly 1,000 people to the hospital. Out there in space is an asteroid that is hurtling right towards us, and we're unsure if we'll be safe. Neil deGrasse Tyson has issued a warning saying that the asteroid Apophis is heading right towards Earth. This asteroid is about 1,100 feet wide and is predicted to fly close to Earth in 2029. Will it impact or will we be safe? That's the question on everyone's minds. So join us as we explore the mystery behind Asteroid Apophis and what could happen if it were to impact our planet. Let's just say Neil paints a grim picture of the event. His warning on his podcast, Cosmic Queries, delves into a pretty chilling topic: the looming danger of giant asteroids barreling toward Earth. Joined by science author Natalie Starkey, they didn't just talk about asteroids. They explored how these space rocks might have actually seeded life on our planet billions of years ago, but now pose a grave threat to humanity's survival. Every day, Earth is playing dodgeball with asteroids and meteors of all shapes and sizes. NASA says we're treated to a celestial light show as hundreds of space rocks blaze into our atmosphere daily. Even smaller ones like car-sized asteroids manage to sneak a hit on our planet at least once a year, causing a bit of a problem locally. But it's the big asteroids, the ones measuring kilometers across, that really keep astrophysicists up at night. Those could spell the end of humanity as we know it. It's a wild twist of fate, according to Neil. He acknowledges that these cosmic wanderers might have brought life to Earth, or at least the material necessary for life to thrive, but now they're the grim reapers potentially ending the life they started. And now we have found the perfect example of a world-ending asteroid. Neil deGrasse Tyson dropped a bombshell during a lecture in San Francisco back in 2008. A hulking asteroid named Apophis, 99942, a whopping 370 meters wide, has been orbiting our planet for ages. This end-bringing asteroid is appropriately named after the ancient Egyptian serpent Apep, known for personifying chaos and evil. Apophis was on everyone's radar back in December 2004 when early readings suggested it had a slim chance, 3%, to be precise, of crashing into Earth on April 13, 2029. Scientists, not just Tyson, raised the alarm bells, warning of potentially catastrophic consequences. Initially, when they first crunched the numbers on its orbit, there was a worrying 2.7% chance Apophis could slam into Earth in 2029. Thankfully, deeper dives into old astronomical records by NASA swiftly debunked that theory, but a slim chance for a 2036 impact lingered. Why? Because Apophis might glide through what scientists call a gravitational keyhole, a tiny region in space where a planet's gravity gets a bit altered. While the odds of Apophis hitting that keyhole are slim, it's not entirely impossible. The keyhole itself is only 600 miles wide. Since Apophis is set to come closer than some of our orbiting satellites in 2029, it may or may not pass through that keyhole. But if it does, then it's set to strike 13 years later, about 500 miles west of Santa Monica. So, worst-case scenario, let's entertain the worst-case scenario here. If Apophis did decide to pay us an unwelcome visit, it would bring chaos. Tyson paints a grim picture. Imagine a collision in the ocean setting off a monstrous tsunami, submerging a large chunk of North America. If it plummets through the center, it'll drill into the Pacific Ocean, plunging 3 miles down, then exploding. The explosion carves out a crater 3 miles wide. The resulting 5-kilometer tall wall collapses, cascading back into the ocean, triggering massive tsunami waves, according to Neil. And that's not the end of it. The cycle repeats, with each iteration lasting about 50 seconds, turning everything in its path into nothing. Houses, factories, everything, all pulverized by a force that could scour the entire west coast of North America clean. According to Neil, the world will hold its breath on April 12, 2029, waiting to see if the asteroid makes its way through the keyhole. A critical moment that could prompt several Americans to scout for new homes. If it manages to navigate the keyhole, brace yourselves. April 13, 2036, could spell disaster for Earth. Still not convinced? Let's get a better idea of how bad the impact of this asteroid could be by taking a look at another meteor event that happened in 2013 in Russia, the Chelyabinsk meteor event. Impact of another asteroid over 10 years ago, on February 15, 2013, the people in Chelyabinsk, Russia, got a rude awakening. This was a huge explosion in the sky, filled with a super bright light and a loud bang, followed by windows shattering everywhere. It wasn't a nuclear blast or anything. It was a meteor exploding over the sky. Although it wasn't predicted, the wild event was caught on tape with a plethora of perspectives, almost by luck, as at the time lots of Russians used dash cams in their cars. Thanks to that, they captured this crazy moment when the meteor lit up the sky as it blew apart. The meteor was about 66 feet across and rushing into our atmosphere at lightning speed. This was a whopping 19 kilometers per second, or about 42,699 miles per hour. About 19 miles above the ground, the blast was so powerful that it temporarily eclipsed the sun. The boom generated energy equivalent to 500 kilotons of TNT, which is 30 times more powerful than the Hiroshima atomic bomb. Thankfully, the explosion occurred high in the sky, so most of that force got soaked up by the air itself. If it had blown up lower or hit the ground, then we'd be talking about a whole different kind of day. But still, it wasn't all harmless. The explosion sent a shockwave ripping through the air down to Earth. It wrecked around 7,200 buildings in 6 cities and hurt about 1,500 people who ended up needing medical attention in clinics and hospitals. Turns out, curiosity caused people to be injured too, as they rushed to see what caused that giant flash and bang. When the shockwave finally hit, the windows shattered, sending shards flying at them. The chilling aspect of the Chelyabinsk incident lies in its stealthy approach. It caught everyone off guard. The asteroid remained undetected until it breached Earth's atmosphere, largely due to its trajectory from the direction of the sun, concealed by its blinding radiance. Interestingly, the same day harbored a less alarming yet still noteworthy celestial event. The Planetary Society had scheduled a webinar to discuss asteroid 367943 Duende, a 98-ton space rock anticipated to make a close pass by Earth. Discovered by a winner of the Planetary Society Shoemaker Grant, which bolsters observatory enhancements, this asteroid symbolized a teachable moment for both Society members and the public. Beyond funding asteroid research, the Society's agenda includes raising awareness about the asteroid menace and advocating for government funding to enhance ground and space-based asteroid surveillance, crucial for preempting potential threats. Thanks to advancements in asteroid detection technology exemplified by projects like the NEO Surveyor spacecraft, our ability to detect and track asteroids like Duende has significantly improved. Armed with such tools, we can anticipate their trajectories early on, enabling proactive measures to mitigate risks and safeguard lives. Hopefully, this means that space rocks like the Chelyabinsk meteor will be detected way before they impact the Earth's atmosphere. Now bear in mind that the Chelyabinsk meteor merely grazed the sky of the Earth. It didn't actually impact the ground as it exploded in the air. Apophis, on the other hand, is predicted to impact the Earth's surface, which could cause catastrophic damage. But those were old predictions, and we've made several advancements in asteroid detection technology since then. So let's take a look at the latest and see if Apophis will truly hit Earth or if we'll be safe. Will Apophis hit Earth? Turning to Apophis's initial assessments upon its discovery in 2004, flagged it as a perilous asteroid with Earth-threatening potential. However, subsequent observations refined its orbit, altering the diagnosis. Contrary to previous fears, the likelihood of Apophis traversing a gravitational keyhole, deemed a potential collision hazard, has dwindled significantly, with recent estimates pegging its width at under 600 meters, rendering a collision scenario highly improbable. That's right, it was first thought to be 600 miles, according to Neil, but it seems that it's actually 600 meters wide instead. Seems our initial calculations were quite off the mark. Early data hinted at a concerning possibility: a 3% chance of Apophis striking Earth on April 13, 2029, inciting widespread alarm at the time. Yet reassessment in light of more comprehensive observations has calmed immediate fears, offering a glimpse of relief amidst this uncertainty. This happened first in 2006 when the initial alarm regarding Apophis was somewhat quelled by scientists who projected its trajectory to pass through a narrow gravitational keyhole spanning 600 miles. This adjustment pushed the anticipated impact date to April 13, 2036, alleviating immediate concerns. NASA's subsequent evaluation in 2008 further calmed fears, pegging the probability of a 2036 impact at 1 in 45,000. a significant reduction. A decade later, the European Space Agency recalibrated this estimate to 1 in 150,000. Despite these reassuring projections, vigilance remains paramount. Earth is perpetually in the crosshairs of asteroids like Apophis. Advanced instruments, including ground-based observatories and space telescopes, are indispensable for early detection and mitigation strategies to ward off potential threats. Understanding the dynamics of near-Earth objects, NEOs, such as Apophis is crucial in developing effective countermeasures. It involves constant monitoring of their orbits, predicting potential keyholes, and devising deflection techniques to safeguard our planet. Furthermore, international collaboration among space agencies, scientists, and policymakers is vital for pooling resources and knowledge to address the asteroid threat collectively. Asteroids, often referred to as minor planets, are rocky objects that orbit the Sun, primarily found in the asteroid belt located between Mars and Jupiter. They vary greatly in size, from small rocky fragments to larger bodies several hundred kilometers in diameter. These celestial bodies are remnants of the early solar system, leftovers from the process of planetary formation over 4.6 billion years ago. The study of asteroids is crucial not only for understanding the history and composition of our solar system, but also for assessing potential threats to Earth. These objects can pose significant risks if their orbits intersect with Earth's path, potentially leading to devastating impacts like the one witnessed in Chelyabinsk in 2013. One of the key challenges in dealing with asteroids is their detection. While larger asteroids can be tracked using ground-based observatories and space telescopes, smaller ones often go undetected until they enter Earth's atmosphere, like the Chelyabinsk meteor. This underscores the importance of advancing detection technologies and increasing surveillance efforts to identify potentially hazardous asteroids well before they become a threat. NASA and other space agencies around the world are actively engaged in asteroid detection and mitigation efforts. Projects like the Near-Earth Object Surveillance Mission, NEOSM, and the NEO Surveyor spacecraft are designed to improve our ability to detect and characterize asteroids, particularly those that pose a risk of impact with Earth. Once an asteroid is detected and its orbit is calculated, scientists can assess its potential impact probability and develop mitigation strategies if necessary. These strategies range from deflection techniques, such as kinetic impactors or gravity tractors, to more speculative methods like nuclear detonations, which could alter an asteroid's trajectory away from Earth. The planetary defense community also emphasizes the importance of international cooperation in addressing the asteroid threat. Collaborative efforts allow for shared resources, expertise, and data, which are critical in enhancing our collective ability to detect, track, and mitigate potentially hazardous asteroids. In addition to their potential threats, asteroids also offer valuable scientific insights. Studying their composition can provide clues about the early solar system's formation and evolution. Some asteroids are believed to contain valuable resources such as metals and water, making them potential targets for future space exploration and resource utilization missions. Moreover, asteroids have played a significant role in shaping the evolution of life on Earth. It's hypothesized that asteroid impacts may have contributed to mass extinction events, such as the one that led to the demise of the dinosaurs. Conversely, these impacts may also have delivered organic materials and water to Earth, potentially seeding the planet with the building blocks necessary for life. The study of asteroids is inherently interdisciplinary, involving fields such as astronomy, planetary science, geology, and aerospace engineering. Advances in technology, such as high-resolution imaging and spectroscopy, have revolutionized our understanding of these celestial bodies and continue to drive new discoveries. Beyond their scientific and existential implications, asteroids capture the public's imagination and curiosity. Their portrayal in popular culture, from science fiction movies to documentaries, reflects our fascination with the cosmos and our desire to explore and understand our place in the universe. Looking ahead, the field of asteroid research faces numerous challenges and opportunities. Continued investment in observational capabilities, computational modeling, and international collaboration will be crucial in advancing our understanding of asteroids and improving our ability to predict and mitigate potential impact events. education, and public outreach are also vital components of asteroid research. By raising awareness about the asteroid threat and the importance of planetary defense, we can foster public support for funding and initiatives aimed at safeguarding Earth from future impacts. In conclusion, asteroids are ancient remnants of our solar system's formation that continue to intrigue and challenge scientists and space agencies alike. While most asteroids pose no immediate threat to Earth, the potential consequences of a collision with a large asteroid underscore the importance of ongoing research and preparedness efforts. By studying asteroids, we not only gain insights into the history and evolution of our solar system, but also develop strategies to protect our planet from potential impact events. Through collaboration, innovation, and public engagement, we can enhance our ability to detect, track, and mitigate the asteroid threat, ensuring the safety and resilience of humanity in the face of cosmic hazards.